Hello everyone. Can you see my screen? Is this thing on? So it's really cool to be back at in-person event, and I want to start by just giving a round of applause to you and to the amazing Android Makers organization. So please join me and let's applaud. I know that we're almost on the last talk, so bear with me more 45 minutes. And just to guarantee that no one's going to fall asleep, I'm also going to ask you to just stretch a bit. So let's put our hands up. Come on, everyone, I know. OK, nice. Thank you. So let's start. I learned a sentence in French, so bonjour à toutes et à toutes. I hope you understand it. And welcome to this adventure of Kotlin and Compose through the multi-platform world. So my name is Mota. I'm from Portugal. You can find me at Twitter at @CFonsMota. I'm an Android GD. I've been programming for Android for the past 10 years, when Android was still grayish, and been playing with multi-platform for the past 4. I'm the founder of GDG Coimbra. I love to travel, photography, and running, and I look to taste the sans-culotte with all of you. Someone told me that this was a really good French beer, so if it's not, I don't mind to taste another one. I've created a couple of materials for this talk, so you can find my slides at my speaker deck. I created a project to talk about Kotlin Multiplatform and Compose Multiplatform. It's on my GitHub. I wrote a book about Kotlin Multiplatform, and I'm trying to be a YouTuber, so sometimes I'm launching videos, so let's have my YouTube moment and say, feel free to subscribe. So let's start. Oh, I'm just going to tweet them after this talk, so don't worry about copying them. So the first question is how to develop an app. So you might have a great idea that you want to implement, or you're paid for that, it's your job, or there is that awesome framework that you want to test, so you create a side project to do it. And this is really important because the project that you want to create is going to define the tools that you're going to use to program. So if it's a proof of concept, perhaps you just want to do something really quick. Sometimes there are projects that are going to take 5 years, 10 years, forever. So the project timeline, it's important when you want to select a tool to work. Along with these requirements, it's also important to know if you have a team, for instance, or if you're the only programmer that's going to develop everything. So another thing important is the team background. So is your team native? So do you have an Android developer, an iOS developer, or there are people from web and they need to adapt to a cross-multi-platform solution? Also, it's also important the project itself. So now I'm just going to show here Android, but we could target a lot of platforms. Talking about the project, the budget, can you hire more people along the way? Or, for instance, you're starting the project and it's already delayed, so perhaps you cannot try a new framework. And as I was mentioning, the targets that you're going to build. Are you going to build application for Android only, iOS, web, desktop, you name it. So there are a lot of frameworks out there. I'm just going to put here 4 of them. And my goal here is just to convince you to use multi-platform. So I'm just going to show you a quick image from, I was on Instagram trying to share something on Facebook. And I'm just going to show you once again this slide and showing you, you see this dialogue? Look, when I started Android 10 years ago, that was the dialogue that existed back on Android. And someone from Facebook forgot to update that component. And this is one of the problems when we were using one of these frameworks. Another example that I saw yesterday on Twitter was someone complaining that was using iOS application, and they were using Flutter for this. And, well, this doesn't seem to be an iOS app, but it is. But the person that developed this library forgot that on iOS it shouldn't be a dialogue. They don't know what dialogues are. So when we talk about frameworks, we need to be careful about a couple of things. For instance, the demo effect, and you're going to see this today, because I'm going to convince you about multi-platform, and you're going to think it's awesome. And of course, like all frameworks, there are problems. Another problem when you select one of these frameworks is that you're dependent to that framework. So I mentioned that you have project requirements, and sometimes projects took for 5 or 10 years. And my question is, what's going to happen in 10 years to that framework? Is it going to still exist? If it's not, what you're going to do, rewrite your entire application, develop the framework and that application. I had an issue a couple of years ago. I was using one of these frameworks, and I developed an app for Android and iOS. And there was a huge redesign when we talk about iOS. And when there is a new update, typically 80% of the users update to the newest OS version. So for 4 months or 5 months, the users were still seeing my app as an old one. The design was old, was ugly compared with the newest version. And once this framework updated their widgets, I needed to update the framework, compile the app, submit the app, and then the users needed to update the app once again. And for these 5 months, I lost 60% of my users. So this is something that you need to be careful. Sometimes there are missing features. Typically, if you want a tool that, typically if there is a feature that it's missing from Android or iOS, they don't implement it. You need to go to the community and see if someone implemented it. You have slower performance. I know that this is always arguable, and in case of Flutter, performance is quite good, but on most of them, you don't, and you start seeing the application lag. And once again, committing to one framework, are you sure that you want to commit the next 10 years to that framework? So I've got a solution for this. It's called Kotlin, namely Kotlin Multiplatform, a language that you all know. So I'm assuming that everyone here has programmed Kotlin, right? Just put your hands up. OK. Just to be curious out here, is there any iOS developers here? OK, nice. This is also for you. I've got good news. So talking about Kotlin Multiplatform. So the first thing, and I think this is a really important concept, it's that it's not a framework, OK? It's an SDK. And with this means that, OK, we're not dependent with it. So it's developed in Kotlin. You can take advantage of all the Kotlin features that you already know and love. It allows you to share your business logic. Kotlin Multiplatform's goal is not to share everything. They want to share the business logic of your apps. And a really good thing about here is that you can start small and just keep adding new features. For instance, you're going to develop a new feature, and it's going to access the network. So why not doing it on multi-platform? And then, as your team starts to love Kotlin Multiplatform, you can migrate existing features. And another good thing here is that let's think about the worst case. Your team doesn't feel comfortable with multi-platform. OK, there's no problem. You can always use it on Android. But I've got a slide just how to convince the iOS folks. Don't worry. And then you can develop the UI as you want. Typically, you should do it natively, but you can use Flutter, you can use any of the frameworks that you want. Another important thing when you talk about Kotlin Multiplatform is that there are a lot of acronyms out there. So a few years ago, you would see something like MPP. So now that's mean multi-platform, and now you can see it as Kotlin Multiplatform, so KMP. And then KMP means that it's going to contain a WebAssembly, WASM, GS, the web, JVM, native, and KMM. Native means that you're going to target to desktop, for instance, Linux, Windows, and macOS, and to iOS, tvOS, and watchOS. And KMM means Kotlin Multiplatform Mobile. That means Android, iOS, tvOS, watchOS. How can you start? I know that after this talk, you all want to start. There is a really great plugin called the Kotlin Multiplatform Mobile plugin that allows you to create a library or an application directly with multi-platform. So it's like 3 clicks, and you've got your initial project. And these templates are updated to the latest version, so you can take advantage of all of these features without going through the pain of compiling your first application on multi-platform. When we talk about multi-platform, another question that a lot of people ask is, OK, but we have Android, iOS, desktop, so there are platform-specific code. How does it work? Because if you develop a library in C++ or in C, you often need to say something like, if Android do this, if iOS do that, and you end up your library to have a lot of if and else just to have different behaviors depending on the platform. With Kotlin Multiplatform, you can do something like this. So there is a keyword called expect, and imagine this simple scenario. You want to define this property, and you want to be on Android called Android, on iOS, iOS, on desktop, desktop, web, web. You get the point. So we're going to use the keyword expect, and it's exactly that. We expect someone to define this. And if in your project you're targeting Android, iOS, desktop, the IDE is going to automatically say, OK, you're expecting someone to define this, so define it. For that, you're going to use the actual keyword. So in this case, we are on Android, and you're going to use actual name means Android. And the really cool thing here is that if you look at here, you're going to see that all your shared code, it's inside a folder called common. And every time that you want to move to platform-specific code, you're going to go to Android main, or iOS main, or desktop main, or web main, and you get the point. So this is how you define platform-specific code. And another question that I often get asked is, OK, but Kotlin Multiplatform, it's in the beginning, so there are libraries for it. There are tons of libraries. So perhaps these are the most famous libraries. So Android, you've got Room, iOS, Core Data, Retrofit, Alamofire. These libraries are quite similar, but they depend on the platform that you're using. The really cool thing about multi-platform is that, imagine, let's merge all of these libraries, and you can have them. You can have SQLite for database, Ktor for network, Kotlin serialization, Kotlin coroutines, etc. So I've got here a list of libraries that you can use. We had a great talk about Coin today, so if you have any questions, the best person that you can ask is Arnaud about that. And moving from libraries on how to convince your iOS team. So a few years ago, the Kotlin coroutines was single-threaded. So a lot of people from iOS were always complaining that, OK, you need to freeze the objects to send from one place to the other. With a new Kotlin native memory model, that exists from version 1.6 and afterwards, you can have multi-threading on iOS, and it works really, really good. I've been using it in production for the past months, and I just removed a lot of code, and the iOS team was way happier now. So how can you convince iOS developers? So Kevin from Touch Lab mentioned that the best way to convince them was to just pinpoint a pain that I have, for instance, core data, and say, OK, you don't need to care about that. I'm going to do it on multi-platform side, and you can freely use it. We use that technique, and it worked. And more recently, we were developing a new application, and the way that we had to convince iOS developers was they wanted to learn Swift UI. But at the time, we didn't have time to learn how to develop using Swift UI. So the agreement that we all did was, OK, so you're going to learn how to use Swift UI, and I'm going to keep developing the features using Kotlin Multiplatform. And they loved this idea because they could focus on learning Swift UI. And now I'm here, and yesterday I was seeing a PR that the people from the iOS team just made on Kotlin Multiplatform, so they love it. It's also important to mention that since Kotlin and Swift are quite similar, the syntax itself, they could easily learn how to do things in Kotlin. So that's also a plus. So iOS folks, I'm hoping that you're next. I think that you can sometimes complain is about the time that the framework takes to be compiled. There are a couple tricks here. You can just compile, for instance, for the target that you're going to deploy your application. In the case of iOS, you don't need to compile, debug, release, and simulator. You can just use the simulator or just the debug one. And this saves you a lot of time. And of course, you can have the CI created for this. My suggestion is always to have your project on its own repo. And you can just generate a Swift package that you can then easily import. A thing about this, there is a really cool plugin that's called Create Swift Package. Unfortunately, it doesn't work with the Mac M1. There are a couple of branches that already give this support. And on my repo, I have the plugin installed there with all the latest developments that you can use. So some key takeaways about Kotlin Multiplatform. So it's Kotlin. Once again, it's amazing. It's low risk. You decide what you want to share. You're not committing your entire project to multi-platform, although you should. It's going to foster your development because you're going to share your library across multi-platforms. It's going to give you consistency because you're going to have one tech stack. So in the end, there's not going to be that phrase that I forgot to implement the caching mechanism or something like that because everyone is going to use the same stack. This also means that if you add a bug, you're going to add that bug on multiple projects. But if we saw the cup as half full, when you fix a bug, you're going to fix a bug on all projects. So that's great. Another really important thing here is that you have a really good and strong community. I had an issue with WatchOS application that I was trying to submit to the store, and basically Apple was rejecting my app because there was some WebAssembly code that was generated and they didn't approve it. And for 2 weeks I was talking with JetBrains, and they were continuously helping me on how I could be overcoming this issue with Apple. So having a really strong community helps when you want to use something that is new. Another question that I often get asked is, there are apps in production using Kotlin Multiplatform? Yes, there are a lot of apps. You've got JetBrains Space, that it's full Kotlin Multiplatform. You have Netflix, that has their studio app as multi-platform. They've written a really good blog post a couple of months ago. I think it was like in the end of the year. And they mentioned that using multi-platform allowed them to develop the application way faster and keep launching new apps. You've got Catch App, the people from SQL Delight. You've got a VMware that shares their business logic. You have Index Maps that shares business logic, offline management data. You've got Strava. You've got a lot of applications that are moving towards multi-platform. So, key takeaway, you should use Kotlin multi-platform. But there's more to it. And when we talk about multi-platform, we've been seeing also a really great adoption with Compose. So we had a really great talk before this, so you're all familiar with Compose. Just to be curious, who's working with Compose nowadays? Okay, no, nice, more than half. Yeah, good for you. Some key or some buzzwords about Compose. You're going to write less code. You can finally get rid of those find view by IDs and all of that. It's intuitive. It's going to make your development way faster, and it's powerful, and it's multi-platform. So apps already using Compose. Twitter just said that they're developing in Compose and they're really liking it. They feel that they're going to have less bugs. Their productivity increased. You also got Lyft with the same sentence. They say that they never think on switching back, so they're doing everything with Compose. But when we talk about Compose, there is more to Compose than we typically are aware of, at least on my case at the beginning. So if you go to the Google documentation, you're going to see that Compose has a lot of libraries. So you've got the compiler, runtime, UI, material tree, material foundation, and animation. And we can split them into two different categories. So you've got the Compose UI toolkit on Android, that it has the animation, material tree, foundation, and UI. And then you've got the Compose compiler and the runtime. And this is important because it's having this separation of concerns, the Compose compiler and runtime, that allows you to have a multi-platform Compose. So about the compiler itself, it's written in Kotlin. It's what transforms your composables into UI. It doesn't use annotation processors, so it's really, really fast. And it's open source, and if you want, you can just grab this link and check the code if you want. I don't know why you should do that, but it's open source. You've got the runtime. The runtime is platform agnostic, so it doesn't know what Android, what desktop is. And basically, it's a tree management solution. There are a lot of applications, there are a lot of side projects that are using Compose without a UI. There are dozens. And then we've got the UI toolkit. So we've got the animation that allows us to create those beautiful animations. We've got the material tree, that's a new material design tree system from Android 12. We've got the previous one. You've got a foundation that gives you all the base components, columns, image, texts, and of course the UI that allows us to interact with the app. So you can write, and if you have a text field, you can see the text there. And this is great because we finally have Compose for Android, for desktop, for web, for console, and for iOS. This is new, and I hope I'm able to convince you to also try it. Before I dive into this, it's important to mention that Kotlin and Compose don't go at this moment perfect. They're not perfectly side by side. So 3 days ago, there was a new version of Compose, and it still targets Kotlin 1.6.10, but 3 days ago also was released Kotlin 1.6.21, if I'm not mistaken, and you cannot use one with the other, so you need to wait for Compose to update, so be careful with that. And there are a lot of amazing libraries that you can use with Compose that give you everything for free. So the company's libraries are great. You've got access to everything. You've got access to permissions, to pager, to swipe to refresh, to all of these components are already implemented, and you just need to call them. It's this easy. Also, a great thing about Compose that I forgot to mention is, imagine that you want to build something with XML, something like a list. On XML, you are going to do something like, you have activity, you've got a recycler view, you have an adapter, and then you have 3 XML files. With Compose, just one line. You've got a lazy column for that. Some key takeaways about Compose. So once again, it's Kotlin, and you all love it. It's low risk. You can follow the same approach as multi-platform, so you can decide what's worth to migrate to Compose. You can use it with XML, for instance. It fastens your development, you can reuse a lot of code, and it's way simple to implement the design system as you saw before. So what we want to do is to use Compose and Kotlin multi-platform for multi-platform development. Just try to have both things. So my first question is how to develop a multi-platform application. And I've created a simple one for you to see. For instance, this is a really simple application. It connects to the Unsplash API, and it gets you a couple of images. And you could be doing this with native, Flutter, or any other platform. For now, we're going to use native. So just a quick preview of the app itself. This is the Android version of the app. So all of this, it's done with Compose, with Kotlin multi-platform, with Compose multi-platform. And you can see that it's way simpler. Basically, this is network request, a bit of database, and that's it. And you can navigate between screens. And then I've used this code, and I've ported it to desktop. Before that, I still implemented the Where app, also with Compose. Pretty simple. And then I ported it to desktop. And you're going to see that this is really a desktop application because I'm just going to maximize the window. See, desktop. You can do that on Android. And then after this, I've also implemented the web app, once again, with Compose. And I know that you're going to be really shocked now, but it also exists for iOS. Yeah. This is Compose for iOS. It's still on its early stages, but you can start having it. There's still no proper way to load images or to fetch images from the web, nor even locally. But it's the beginning, and it's great to see that there is someone also trying to have it on iOS. So just a quick overview. So all the business logic is shared across all of these platforms, and it's working perfectly fine. I didn't have any issue with that. The UI, it's developed with Compose, and Android Wear, and desktop are being shared, while web and iOS use Compose, but at this moment, it's still not possible to share it. So let's talk a bit about challenges, how to share everything. So the biggest problem when you try to have your Android app running on desktop, it's a file called R-class. The R-class refers all the resources that your application has. And this is Android specific, so you don't have it on desktop. Also, there are specific components like lifecycle, navigation, view models that are Android specific. So you need to give this support for the desktop. So Kotlin Multiplatform to the rescue. And we're going to give this support. And it's quite easily to give it after your first attempt. So you need to create your platform-specific implementation. There are a lot of libraries that currently support Android and desktop. And sometimes when they don't support it, you can almost easily add this support. You can add this support if the library itself doesn't use something that it's really Android-specific. For instance, the company's libraries were given that support by just adding the JVM target to it. And with that, you are able to run it on the desktop. So a couple of libraries that are worth mentioning. There is a version by CR10 about the company's libraries that they run on Android and desktop. And is pushing these libraries quite often, so you're basically using almost the latest version of the company's libraries. You've got Camel for image loading, from fetching images from the web. The project, it's not currently updated to the latest version, so if you are using Tor 2.0, the project won't compile. So I created a pull request for it to give this support. There is the Mocha resources library that is going to allow you to share your strings across Android and desktop. And these Mocha resources also work to share your strings across iOS, across web, across all the platforms. And this is really good because we can just have a project that are strings, and your apps are going to have the same strings. And you end up those things that the iOS app had some strings, we add another ones. Now you have a common repo for that. There is also the pre-compose library, and this pre-compose library, it's really, really good because you can have the view model, the live that, etc., available for the desktop. So if you're already familiar with Android, you can use them on the desktop. So I mentioned that resources are the hard part here when we talk about Kotlin Multiplatform. So let's see a quick example. Imagine that you want to load an image. So we want to load this Kotlin image. On Compose, we'll do something like this. We're going to say that the painter resource, it's going to use the R-drawable Kotlin. And then Compose requires that you add the content description, thinking about accessibility. So you need to access the R string and then access the string, in this case, Kotlin. If you want to do the same thing on desktop, well, it's a bit different. You don't have the R class on desktop. So we're going to do something like this. We're going to access the images from the resource folder, and you can, for instance, have the string hard-coded. And we don't want that. So how can we give this support to load the images the same way on both platforms? So once again, Kotlin Multiplatform comes to the rescue, and we need to create an implementation. As you saw before with the expect name, we're going to do the same thing, but now thinking about resources. So we're going to use the common main to define the declaration, and then we're going to implement it on Android and desktop main. Let's see an example. So the best way to have this working at this moment is just to create a function that's going to be a composable function that refers to an image. So in this case, I've got my composable ICAbout, and I expect someone to define what the icon about is. So someone needs to define this. Since I'm targeting Android and desktop, I'm going to say that actual ICAbout for Android, it's going to use the R class, drawable, and then ICAbout. And then for the desktop, I'm going to access directly the images underscore slash IC underscore about. And with this, what I'm going to call from my code, it's going to be the icon about, and depending on the platform that I'm targeting, it's going to call one function or the other. This might become a bit tedious, because if you have a lot of images, yeah, you need to create this for all of those images. This is the tedious part for now. Of course, you can also create a library for this, if you want. I'd be really appreciated for that. But I'm assuming somewhere in the nearby future, someone is going to give a better support for this. Talking about text, you have once again the same problem with strings and the R class. So imagine you've got the hello world here. To do it with Compose, it would be something like this. You're going to say that text is going to access the hello world string. and do the same thing on desktop, you're going to have, for instance, an hard-coded string. So what we want to do is to stop using the R class and follow the same approach that we followed before, just so we can support strings for Android and desktop. So for that, it's quite easy. You just need to use this library, the Mocha resource library, and then you just need to add the resource generated to the class path. And then you're going to create an multi-platform implementation just to load the strings. So basically, you just need to create, once again, using the expect keyword, you're going to define the get string. And then you need to create the actual implementation for each one of the platforms. So we're going to send the app context that you've got on Android. And from desktop, you just need to call the localized function. Now, if you want to call the get string from your code, you just need to call this get string mr strings hello world. This mr means Mocha resources. It's where your string file is. Basically, what you're going to do is to move the strings file from your res folder to your shared folder, and to inside a folder that's called mr, and then called base or fr, for instance, for the French translation, and so on. I also talked about the web. So where are we at the web? At what stage? So the paradigm here is a bit different. So instead of having all those columns, text, and so on, we still need to use divs. So if you look at this code, you might be familiar with it, because it's basically the same thing that you do, or a similar thing that you do on your web pages, but now with Compose. Of course, you can give a support for this, and instead of writing this code, you can put it inside a composable function and do something like this. But then you need to implement expect for Android, for desktop, and it's going to be quite tedious to do this for all the components out there. So sharing logic, it's working fine on the web, so feel free to share your business logic. You just need to be careful when you're going to generate the final file, because the GS file might end up with a couple of megabytes, so you need to minimize it, you need to compress it. So it's not as direct as it is on the other platforms, but it's working pretty well on the web. Sharing the UI, it's still on its early stages. I'm hoping, once again, that on the next months, this will be way easier. So iOS, the same question, where are we? I think you all know we are here. So sharing logic on iOS works really, really well. I have an app on production for the past year, and although there was a couple of challenges when we tried to add a new feature, everything is working fine, especially with a new Kotlin native memory model. It's working really, really good, and I don't even remember the last time that we had a crash, for instance. A crash that we didn't know why it happened. Crashes, unfortunately, sometimes we have. Sharing the UI, well, it's almost impossible nowadays, but once again, this is something that it's still on its early stages. I think there are 2 samples on JetBrains GitHub that are really hidden, but this means that there are people working on it, so let's hope that for a nearby feature, we're going to at least be able to have a similar function that we have on Android. Some key takeaways on why this is important. Let me start with a question. So, who doesn't have an Android here? Just try to... Oh, everyone has an Android. No iOS. OK, so I know that you're hiding. So basically, at my company, there are people that don't have an Android. I know that, shame on them. This is great because I could easily port my Android application to desktop, and this allowed for other people to test what I was developing. It allowed us, since we were building a couple of things at the time and we didn't have Androids for everyone, they could see the state of the Android application, they could report more bugs on the Android application. But in the end, this is great, and it allowed them to test. And if we think about the business side of things, they can now sell this as an isolated project, for instance. Or if you think about you and an application that you have, you can try to reach new markets quite easily just by sharing your resources. Also important to mention that new platforms are on its way to be supported. Once again, web is giving its first steps. iOS seems to be almost there, almost here, so let's once again wait for the next months. Some key takeaways trying to get everything together. So this was my best approach to show you how everything is. So Kotlin Multiplatform Mobile is stable-ish. So officially it's not yet stable, but from my side, from the people that are using Kotlin Multiplatform on production, they're quite happy with the result. So I'm hoping that on the nearby future, you also are going to be. Compose for Android is more than stable. Compose for desktop, it's stable-ish. So there are a few things that you might still have some problems, namely with the window API, but it's getting there. For web is alpha, for iOS, it's starting. About documentation and samples, there are a great lot of projects out there, but there isn't yet the documentation because this is still being developed. And once again, the community is amazing. If you have any questions, please go to the Kotlin Lang Slack. That's almost all the questions are answered there. Or you can hit me on Twitter. I compiled a couple of resources. So about Kotlin Multiplatform, once again, the Kotlin Slack. There is the Kotlin Multiplatform book. You can go to the Touch Lab, to the Ice Rock, GitHub, for instance. They have a lot of libraries that they want published. There is a great number of talks on the Kotlin 1.4 online event. For Compose, there is, once again, a lot of samples at the Google GitHub. The community is, once again, really, really strong. You have people that are publishing books about Compose, and you've got the Twitch from Intelligible, that it's an Android, a Google developer that created an entire application on Twitch, and it's really cool because sometimes he found a bug and he was solving the bug in real time. So go check them. And I think we still have a couple of minutes. So questions?
Hi, thank you for the presentation. You mentioned that you have published an iOS application to App Store, so it probably means that you find the solution how to link your iOS code, UI part, probably on Swift UI, with the shared library, Kotlin Multiplatform library. Can you give some hints of which framework you used for navigation, probably for downloading images, which environment you use? Is it AppCode? Is it Xcode? How do you index, how do you go inside this shared library to see a source code if you use AppCode, if you use Xcode, or something like this? Thank you.
Okay, thank you. That's a really good question. I'm going to try to see if I don't forget any part. So I usually use Xcode. The most simple answer about Xcode, it's free. And it works really, really well. It's what the iOS team was using for development, so it's what I'm using. About navigating through the source code, there is a really good plugin by TouchLab that allows you to even debug your shared code. So basically you need to install this plugin, say that you trust it, and it automatically also gives you syntax about your shared code. Of course, it's not the same as debugging it on Android Studio on an Android project, but it works fairly easy and it allows you to understand what might be happening wrong. About the project itself, so basically I've created all of the projects that I've created. I've created libraries on frameworks with a shared logic. So I've got network requests. I don't have an image loading library, so you still needed to use the ones from iOS. But all the rest was done using multi-platform. And this is a good question, because, for instance, there are times that you don't have all the code on the multi-platform side. And a really good example about this is, for instance, on network requests, you've got Ktor, but you don't have anything for SSES, meaning server-sent events. There is no library about it. And what I did at the time was, okay, I didn't have time to implement this from scratch, so there was no problem. I was still using Ktor for all the network requests, And for SSCS, I was using the native library, so there was an iOS framework that I was using for that. This is the great part, that if there is something that it's missing and you don't have time to implement it, because our jobs are already quite stressful and you have a lot to do, so you can still do it natively without any problem. Did I answer everything, or? Sorry? The navigation between screens, once again, that was done with SwiftUI. I had a project where I've implemented a view model that allowed me to not really navigate, but to populate my views with data. What I've noticed was the iOS team didn't like how the framework was behaving, and then we rolled that part back and we had an MVVM instead. Talking about this, a really cool thing about iOS, if you can use the async await, it works really, really good now with coroutines. So you don't. There is a lot of Kotlin multi-platform projects that use callbacks, and I think on my sample I'm using callbacks in one example, but you can just use the async await now to get the data, and it's a more cleaner approach. You don't need to have all those completion handlers that iOS people don't like.
Hi. Do you have experience with server side of multi-platform?
Yes and no. So basically what we moved to, when we moved to Kotlin multi-platform, we also shared a part with the server side, but I wasn't able to convince the server team at that moment because we were using Quarkus, and Quarkus is really complete, and its integration with Kotlin, it's not yet the best one. What we did, and it was one of the best decisions that we took, was, for instance, our data classes are shared across the server. So every time there is a change, we're notified by it, either because the library built once again or the project doesn't compile. So this guarantees that we're all using the same data classes, and that's what we're doing with the server. I'm hoping that in the nearby future we might be able to use Ktor for this, but at this moment it's not on our roadmap. More questions?
Hi. I was wondering how does Compose on the web works under the hood? Does it output HTML or do you know?
Yeah, that's a really good question. That's way far deep that I'm aware of. No. I can look it afterwards, but some UI toolkit that they developed, I'm not sure about that. Being said, I know that JetBrains is starting to have a lot of their projects. They start to have Compose in it, but it's still on its early stages. It's good for pet projects.
Hi, thanks for your presentation. One question: if you had like an Android-only project, would you like use Kotlin multi-platform, even though you don't have like the needs to do like a web or iOS or desktop project?
Yeah, that's a really good question, because when I was creating this presentation, I thought about that, and I noticed that, well, I've been developing multi-platform for quite some time, so I'm more familiar with these libraries that perhaps retrofit. I don't use retrofit for like 2 years. So yeah, my answer is yes. And not only because I'm already more familiar with these libraries, but because thinking about the future, if I want to, let's imagine next year, add an iOS application, I would already have that part ready. More questions? More questions? Oh, okay.